Welcome to another episode and video on my fischertechnik driving robot Discovery based on the TXT controller. TXT controller is running embedded Linux and is programmed in Python using OpenCV to grab images and using touch sensors for the objects and a lamp to signal things, events. As you can see, the display on the interface is not a standard menu, but is now displaying a live camera image. So possibly that I can see when things do go wrong. Well, depending on, of course, the images that it takes along the way. So, since I do not know if these images on the display are OpenCV, I doubt it, then I'll just have to see whatever happens. So let's see if indeed anything happens. I start the program. And I expect traditionally to end it in error. It takes a bit of time. A long time even. And this is a very long time. Now it does something. Camera connected. There it goes. And ouch! There is a problem now. Because the touch sensors are too low. Well, not really too low, but as you can see from here, it touches the object, but the object is right in the middle. And the sonar doesn't do anything. It just goes right on. And that is problematic. So it should stop upon approaching with the sonar. Clearly doesn't. So let me check for when it should do something with the sonar. If anything, of course. And that is larger than shorter than 10 centimeters, and then between 4 and 10, and then it should slow down and the lamp should go. Well, as far as I know, nothing of that happened. So let me put it back. And see if this object does anything. Another thing is, of course, that given the fact that the object was here and it goes straight there, there's another trajectory diversion. So what happens now? Let's see. I hope not another very long wait. It's now pointed straight at the object according to the camera. That's good. And yes, this is another very long wait until the program actually does something. Yes, now it does. And a camera thread error. So I have to try again. And why does it wait such a long time? It's a very good question, and I can't answer that right now, but I think it has to do with that active camera. But let me just see if that is so. Really takes a long time. Camera connected. There it goes. And it did not say any contact, but it stopped for what actually? I have no idea. Well, there's an OpenCV error again, but there's no contact and the distance is way too long. 19 centimeters. No, this is not going well. Let's have a look. Alright, so let's examine the output. It has clearly completely missed this object, and by diversion, of course. And if we see here, distance is 19 centimeters. Here it says that the first one is between 10 and 15 centimeters. Earlier than that, there is simply just contact stuff. And after this, there's no mention of any distance. So that's about it. Then a failure. And if we look earlier, this is the very first distance measurement, which is clearly between these limits, and it should have done something. Did it do something? I can't tell, unfortunately. But since there is no mention of distance anywhere else before it ends in OpenCV, I can't say about it. And that's the first run of the program. Now, according to the program, it should set speed, and the diversion cannot be caused by this because these are the same speeds. And a test with the walking robot has also some thoughts cast about this, because if you have a diversion which is it is to the other side, this one is a curve to the left, while you can regard the trajectory diversion with the walking robot with the same controller, just slightly different firmware. It is a curve, a very strong curve to the right. Now, as for the images, that is a different story, because although this has an image which probably causes a big delay, using OpenCV for trajectory correction is going to be tough, because these are the only two images being taken, but they have both 0 bytes, so they are completely useless, and that is a problem, a very big problem, because if I want to use OpenCV for course correction, then I obviously can't use 0 byte files. how to go on from this? Well, using a larger distance, first of all. See if it then, with the diversion, completely misses both objects, or touches one object and then pushes it forward again, because with this one, clearly the sonar didn't work with, well, this is set speed to 128. This is a reduction. Here, a reduction to 64. And finally, stopping between 0 and 4, or 2 and 4, assuming that the least reliable distance is 2 centimeters. Anyway, what to do? Well, I think just another test on larger distance. Let's see how that works out. So, at a larger distance, the object barely visible on the camera now, and I mean the onboard camera. So, let's see whatever happens now. Starting the program. Will take a long time again, probably again because of the active camera on the display. And on this distance of about 30 centimeters or more, the sonar will have no effect at all. And it has a network error. So I'm interrupting and starting again. And waiting and waiting. Now it goes. And yes, something happens, but not exactly the way I expect. It ends with an OpenCV error, but does it also touch? So let me take ROBOPro, select the proper interface, network address that is, and now what has happened? Absolutely nothing. The sensors, and then I mean that sensor and that sensor. Well, that sensor obviously has not yet, but that one is touching somehow, or that I can see, but ROBOPro says no, no touch. So then the image, what has the image done? Again, 0 bytes. Okay, so now I'm going to do it again with the camera shut off. So here again, and okay, camera down. And the object in its place again. And now let's see what happens. Much further away, by the way, like this. That's not doing anything. It does do something, but yeah. And that leads to what? Nothing. That leads to nothing, the same situation. So a diversion, and then it grabs images, 100%, oh no, 100% copied, but it does have good images, but is it touching? That is the big question. So let's see for that. So first conclusion is that with this result, no images being copied, that will only happen. Oops. That will only happen with the onboard camera disabled. So now let's see for which one shall I take? 39. That is the very first image being taken. Then 50. Very close after that. And then well, this one is clearly taken after it collided wherever it may have been at that point, either at first collision or somewhere else. So when I want to have the images and a course correction, I really by the way, how many images did I take? That is 1, 2, 3. Oh wait, this is a gray image. Ah, see, that's the whole point. It makes gray images as well. Yeah, it makes just 3 real TXT images. So I have to change that. And I have to, it writes and it makes an image every so much time. So what is the best way to cope with that? Because if it writes, say, half a meter and it takes only 2 images, that's not good enough for course correction. Not in the least. So I really can't tell if this is where it collides or where it collides with the object or where it collides with the standstill. That's a very interesting thing to know. But once again, let's we have a sonar as well. Where does it go to the sonar? 11, and there's nothing after 11. 53 centimeters. So first a 53 centimeters, and then an 11. but here is a camera action 0, and there is another camera action. Nowhere. Here 10 to 15. Lamp on. I didn't see a lamp on. But this shows that my algorithm has to be changed. Definitely. Otherwise, neither picture taking nor the sonar has any influence. That's one thing that's sure. But how to do so? Alright, so what does this mean? Well, let's forget about these images. That means that I probably have to add more imaging. So what image is taken here? Camera action 14. How do I know that this camera action 14 is actually being executed? By yes, by what actually? Oh yeah, right. 13 is it is time, and here this is 13 by this number. So in this case, which is pretty important to know that sonar between 10 and 15 centimeters, it is this one. Well, if you take this picture, well, this is not a picture that you take at a distance of 10 to 50 centimeters. It's much closer. Well, if we take a look at this code, it has been taken apparently at this moment, when it was between 10 and 15 centimeters. Maybe 11. And all the other pictures were taken, the usual pictures were taken at point 0. And when is point 0? Here. This is point 0. When it starts riding, driving, whatever. So what to do? What is the best thing to do? I think that I need 15 and 13 and 13 and 12. I need many more points with the software to take an image, and this as well. 13 between 10 and 8, 8 and 6, 6 and 4, and then I will get an idea of travel distance, and only then. Because this image and this timing, 10 and 15, no way. Oh, and corrupt JPEG data, I still have no clue what it is about. Still have no clue. So, this is going to be quite an adding process, adding and editing, because it's quite a lot of stuff that goes on. Well, this is line 184. This is line 211. So 30, almost 30 lines. Then hopefully no mistakes. Oh wait, I should begin here. This is 212. That's even more. 16 minus 12. It's 50 lines. And then times 2, 3, 4 for the number of images being taken. Nice job. Last part for this episode. I have changed a little bit in the algorithm. I changed between 10 and 15 to between 12 and 15. And added a new camera number, of course. So now it's time to see whatever happens. Not very high expectations, by the way. Waiting for the error to come. Something happens and ends with OpenCV. And the only image that is taken is right at the beginning, which is let's see. Oh, that's an empty image. Okay, I don't need empty images. Let's go again. Camera connected. That is not an empty image, but it doesn't do anything either. Now it does. And it stops. OpenCV error again, but oh, that's interesting. First image being taken is a nice image, and then also, and it ends with an empty image. Totally empty. So let's examine the last good image, which is from quite a distance, about here. And that image is, well, not worth viewing because it's empty. So here is the last image being taken, or even maybe here. So this needs some improvement. And with that, yeah. Still work to be done. Thank you for watching. If you like this video, please subscribe to my channel. Give it thumbs up. Leave a comment. Much appreciated. You can also follow me on Twitter. If so, retweet and like, leave a comment. Also Instagram, please like and leave a comment. Please donate to keep videos coming to you. Much appreciated. Also, you can become a patron and have your name mentioned depending on the pledge you make. Either just on my website or on my website and with the video on some place. For more information, please see my website. And this is obviously going to be continued. For now, once again, thank you for watching. Bye bye.